Alright, continuing on with my design. It's actually coming to an end pretty soon, I think. There's still a few things to do, and right now I'm just creating a bit of openings in the ground enclosures that I have around the analog circuits. So I'll just finish this footprint, and then I'll go to the schematic and continue the work on the schematic. So what I do here is just I'll copy the bias so that I have a stitching bias all around this ground enclosure, and we have the signals that will come in here. So let me just change this grid to 0.5. So let's place them at 2 millimeters. Let's see. Oh, I can actually move this. Great. So we have around, yeah. It's not going to be very symmetrical. This just connects the back layer to the front layer. And I like to make the vias part of the footprint, so I don't have to worry about them being moved by the push and shove router. So when it does this automatic push and shove, it can move the vias that I place manually. But making them part of the footprint makes sure that the vias are always in the same place. And also doing this kind of thing with a ground fill is not the same thing either, because the ground fill can be broken by a track, for example. Now let's place one there, and then copy this circle there, and one more time, and this one will go on the back layer. There we go. Save this. And update footprint. Yep. And then we have the signals that will come out here. That will be the I to C and a few control signals, I think. Yeah, and the VDD 3 to 3. Is this right? This is 5 volts. So we would need another one that is 3 to 3 volts. And it only goes there. Let's see, I have this power layer where I have all of the power connections. So I could, let's see, I would need to take this one out to I don't think actually I have created any fill for the 3 to 3. I've only created one for 3 to 3 MCU, but not for the main 3 to 3 supply. I have the 3 to 3 supply here, so I can see where it connects by control clicking on the net. So it goes, yeah, it goes pretty much around the peripherals here. So what we could do here is just make sure that we have just a connection from this fill somewhere here, and then once I've routed all the other nets, I can do the power routing last. Let's see. So what would be a good way to put this? I have ground there. So this is actually, yeah, this it's better to move this one. Let's see. I have to hide the footprints because if I don't hide the footprints, I always select either the ground fill or some other footprint. So it's quite annoying. So this can go here. And I'm going to have grid set to 0.25 for the fills. And I'll add another corner and another corner. Let's see, do we actually need this one? Actually, we don't need this one. This one goes to, let's see, this one actually needs to cover that via. So, is this, let's see here. So, if I control click on that one, I can see that the 5 volts needs to go mainly to the chips there, and then there's one there. So I need to just make sure that this one covers that. This ground fill here, which essentially I could remove that corner and just bring it closer. Yep, and that one goes there. I can move this via a little bit, and then just connect these ones. Why do I feel that this is not aligned? It seems aligned. Okay. And then we have this one. You know what? I'm fed up with this. I don't want to right click anymore. So I'm gonna see if I can figure out how to assign a key, a shortcut for that. I think there was some place to assign the shortcuts. Hotkey options. Edit hotkeys. Let's see. And I cannot search for that menu item. It doesn't even seem to be here. Create corner. Where is create corner? Create array. Interesting. How does this? So let's see if there is like fill and fill all. Maybe there needs to be some kind of option on the menu item to make it available in the hotkeys. there? No. Is this maybe only for the menus? For the main menus? Interesting. It's almost that I feel inclined to have a look at the source code and see what exactly is happening there. Let's have a look at the KiCad source code. I'm going to bring up the source code. And we'll have a look if we can find, I suppose it's going to be a string, just create corner. Let's just search for this. I'll search for it in PCB new, so grep create corner PCB new. On right click. So apparently they don't create any any hotkey for it, which is like, okay. Let's try to create a hotkey for it. Maybe they just forgot or something. So create corner. And let's see, hotkey. I suppose that this needs to go actually into some kind of, let's see, corner. Okay. No, maybe not. I'm going to add it at the end, so I don't screw anything up. This is an enum. If I add it in the middle, I might screw things up. For example, if it's saved somewhere that this key has this particular number, I don't want to screw it up. So H key, hotkey, create corner. Is this everything I need to do? I don't know. Let's see. So there is a drag item, and this would be create corner. And this is presumably some kind of descriptor for the board editor hotkeys. And add menu item, drag zone. Right. Let's search for. I just want to figure out if there is if this is used somewhere. So H key drag item in PCB new. So hotkeys board editor. So it seems to be that in this file we have, let's save that one, and let's go here. So then there is a bunch of callbacks that get called in PCB frame. And the way KiCad source code is structured is that they basically, I think they basically split the same class over multiple C++ files, which makes it hard to find what one is looking for sometimes. Let's see. So I'm curious if this is gonna take too long time. I'm just gonna let it be. But if I can just quickly figure out how to do this, then this would be very helpful. And obviously, it seems that they're not creating a hotkey for that particular command, so it could be good to add one. So they add the menu item for the drag zone, and they add the same menu item there. So maybe, let's see what else there was. There was create corner in tools point editor. Right, so I don't think point editor has anything to do with this. I think it's probably on the right click here. And do we have ID pop-up PCB drag? Oh, this is an interesting method of doing it, I think. So let's see. And then presumably it sends this event, process event. Okay. One hotkey, move item. Would this work? Maybe? Let's see. Create. Let's place it here. Hotkey. Create corner. And this is not the best place to put it. Actually, what I'll do is create corner here. And then I'll just make a function for this. Create corner. And PCB new hotkeys board editor. Oh, that's E schema. So let's see. Close that one. I have common and PCB new. PCB new. Hotkeys. Like global variables for that kind of crap. Yeah. Not the best code layout. So where do I put this? Yeah, screw this. I'll just make it. I'll just put it here. And then would that actually work even? Could work. I wonder if there are any hotkeys that are associated with this copper fill that actually exist. Okay. ID command. Okay. This is probably not the best place to put it. PCB edit frame. On hotkey. Actually, I can just call it hotkey corner ops. And then I can have a hotkey for the for creation and deletion of the corners. Okay, so what I need to do now is I guess we could do like this. So we just send this event to the main event handler. I think it's an integer event type, yes. So and then switch hotkey create corner. And event would be let's see. ID PCB. So ID PCB add zone corner. Let's go back here. And we'll keep it just at the break. We'll just keep it just at the break there, and I'm not going to add any other commands here. I'm just going to try to handle the create corner first and just see if it works. So this will essentially just send the event to the main event handler. I think this should work. Let's see. So if you haven't been watching this video from the beginning, I got a bit fed up with not having a shortcut for this create corner thing, because it actually appears in different places depending on how the menu appears. So I always have to look for this create corner, and it just takes. I want to have a shortcut for it, but I looked at the shortcuts in KiCad, and I don't have any shortcut for this particular menu item. Let's see. Is the stream still alive? So let's see. I think it should be alive. So I was compiling with 8 threads and using up all of the CPU power. And while streaming, that's not a good idea. Yeah, it seems to be alive. Okay, so I'll just build it with just one, which should be the default. So I don't know how much of the stream got garbled up when my system got really slow. What I'm trying to do here is just quickly add a method to assign a hotkey for creating corners on a copper fill. And it seems to me that KiCad didn't even create that placeholder for a hotkey for that action. So I'm gonna try and quickly add it. And if this is not gonna work or it takes too long time, I'll just skip it and move on with the PCB layout. But I think it's still fun to see if I can quickly add a hotkey for this functionality. Let's see. This seems to work okay alongside the video streaming, but it's quite slow. Okay, while this is compiling, I can probably modify some other parts of this. Actually, no, this is not going to work. This is getting too slow. The video encoder takes a lot of CPU power, and compilation also takes up resources, as well as the renderer. Let's have a look at some of the things that need to be fixed here. One of the things that I've noticed here after doing this placement is that I have the Hall sensors that go out to this motor, the motor number 1, the driver number 1 here, and they actually end up going to the lower part of this chip here. And then I have the Hall sensors on the opposite side have to go up here. And this is not optimal, so I think I'll probably rewire the Hall sensors so that this one goes there, and this one that is closer to this side of the PCB gets connected to motor number 2. That is going to require just reassigning the timers that are used for reading the Hall sensors. Maybe I can continue here, just creating corners manually like that. Okay, create corner, and this goes here, create corner. Maybe by the end of the video I can have a shortcut that does this. I have to make sure that I have 25. So it's 0.5 millimeters between them is 0.25 clearance. Okay. And then on the top layer, get this moved there. No? Okay. Oh, this is annoying. Come on. Can I not just move it over there? I want to have the toolbar here, and then this box all the way to the right. I can't move the toolbar. The toolbar is impossible to move. Alright. I have this pin AP reset, which will need to go over there. Let's actually just lead them out here. This one is... Yeah, they'll have to go in the back layer. All of them. Okay. Should it go before? Yeah, I'll place it a little bit higher up here, and then let's see. Actually, no. This will go here. Pretty slow now when I'm compiling. Seems to work. Use 0.1 for the grid. And move this one a little bit higher up. Not too much though, so that the vias don't end up on the pins, on the pads. So this one can go here. And I try to click as I go, because if KiCad gets into this state of trying to route this track around the whole board, because it's trying to optimize something, then I don't have to reroute the whole track. Because when it gets into that state, it's impossible to make it sort of to make it abort that function and just let me continue routing the track. I have to go back and then I have to reroute the track. Okay, so this, the only thing here is the VDD3D3. And refill, and then this should disappear. Right, now it disappeared. Okay. This one is VDD3D3. We don't have any more VDD3D3 anywhere, so I can just route this. Let's see. This one I think is 5 volts. No, this is the regulator that comes from the Ethernet driver. I could have routed this with just tracks. It's mainly a matter of taste here. I think it's easier to route power with copper fills, because copper fills can go around things and they can automatically connect to the bias. But I think it would be not very good to have the copper fill on any outside layer where I also have signal tracks. And also where I have pads primarily, because I don't want copper fills connecting directly to pads. I want to have full control of how the pads connect to any power rail. Primarily the ground. That's where I definitely don't want to have copper fills. So this one, for some reason, this one is not connecting. I don't know why. Maybe I should refill. Maybe then it will connect. No? For some reason this doesn't really connect. Why are these bias not connected? VDD3 This one is supposed to be connected to this one. Maybe the track is actually not long enough or something? No? What is the issue here? Interesting. Why does it think that this is an unconnected track? Maybe it's because of the... That is weird. That is very weird. Could it be something else? No? It's supposed to be that pad. Could be because the areas just touch, but that's usually not a problem. What if we make this overlap? This is going to produce an error, I'm pretty sure. Once I run the DRC. Huh. Seems to work actually. Let's run the DRC. How's it going with my compilation? 75%. Is it really required that the areas with the same net overlap in order to actually connect as far as KiCad is concerned? Let's see if this produces an error. I would expect it to produce an error only if it's different nets, but I remember that this functionality had some issues. Okay. Next boundary segment. Yeah, this should be. Let's see. Okay, so this didn't produce an error, but it didn't connect them either. So let's move this slightly down like this. Okay, so if I move the midpoint, I can't align properly, so I have to move the corners separately. Moving the midpoint messes up the alignment. Okay, so now this should connect the copper areas. And it's still not connected. That's very weird. It still complains that that is an unconnected net. But if I do like this, is this going to remove the unconnected net? Yeah, like what the hell? If only one corner is connected like that, the unconnected net is removed. If I put it like this and refill, then it's not removed. What the hell? This is extremely weird. This is definitely a bug. Okay, maybe this one is like offset from the grid. Maybe that's why it's complaining. No. Okay, this will actually complain about the zone being too close. I'll make the zones transparent. Yeah, this will have to go there. Like that. So, what if I add a corner there? And then another corner there. And make them overlap like this. Will they connect? No. Yes! Yes, that worked. Great. Okay. Let's have a look at footprints front. And I also have this USB connection here, which unfortunately, because I want to route it on the same layer, I have to go and cross a bunch of tracks here and make them go underneath, and then it kind of becomes a long connection, a long differential pair. So I was thinking that maybe if I move this USB connection here, then I only need to have a shorter track that goes almost straight to the USB connection. Come on. So what I could do to move things around here, I could move that block. Since it's already rooted, I don't want to undo the routing there, so I'll just move this one block, and then I'll move this one. And this would be the address selection for the CAN bus, for the CAN open. So this can go probably there, and then this one, let's see. Yeah. I have to break those connections. Actually, I think that it's probably better, because I have some connections, like even though these ones go on the back layer, there is also a few more of them coming out here. This would be the SPI connection for the CAN-FD interface. So should I actually move the USB there or not? I think I'll move the USB, and I'm going to be routing the connections that belong to this CAN interface will be routed on the bottom layer. And they will actually end up going more straight here, so they won't have to go all the way there. And that will free up some space here as well. Let's see. USB connection can go here, and the USB is sticking out a little bit from the board. So put it by the PCB edge there, and I have the indicator LED there. So then I'll just go to root the differential pair. Before I do that, actually, I'll just check for the, let's see. I pretty much have it already set in the settings. I was thinking about the width of the track and the separation. I need to double check it. Yeah, I'll double check it. Let's see. So USB would have to be let's see. I think it's, is it 90 ohms? This be 90 ohms. Yes. So the differential impedance should be 90 ohms. So it's slightly different from the Ethernet connection that I had. I would have to set this one to 45. And let's see. So if I use, let's see, so maybe if I have a spacing of 154 and the width of the track, yeah, let's make it 0.31. Then I get differential impedance of 90.6. Yeah, so about 31. Okay, so then let's set the differential pair thickness. Differential pair. This would be 31 and 54. This is much better. So I would have wrong impedance on it. Let's see what impedance I would have on it if I were to use the 154. I would have 122 ohms. That would be way out of spec. So I'm routing this on the top layer because I've based my impedance calculation on this layer being 0.2 millimeters from the ground layer. So I have to route it on the top layer, and I can't put any bias along the way. Sometimes KiCad doesn't go all the way because the tracks are too thick here. Maybe I can make the tracks thinner. What if I use, if I increase this one to 0.2, get 94, maybe then I could decrease this one to 25. No, they have to be that thick, it seems. Okay. Yeah. Let's move this Y a little bit. No, don't mess up the track. Seems to be not possible to modify the differential pair connections. It kind of feels like KiCad has just implemented this functionality and that it's still not perfect. Okay. That will have to do. I'll remove the bias here and also here. And this can connect. This is not really critical, so this could go through bias. It wouldn't really matter. But now that I've moved the USB, I should be just using continuous tracks here. It's better to just root first and then to make them pretty. Although if there are corners, KiCad doesn't seem to be able to create them properly. So I have to create some corners and then I can move the corners, which should be easier. But in this case it's stuck. Why is it stuck? Is it because of this one? Why can I not move the tracks? It doesn't seem to be stuck anywhere. Is it stuck here? No? It's not crossing any pads. Usually that happens if a track is crossing some pads, but in this case it doesn't seem to be the case. So maybe it's just too close. Oh, come on. This is some of the annoyances with KiCad. So the mouse cursor has to be precisely on grid and in the middle of the track. So if I put it there, it's going to jump back. If I put it there, it's going to stay there. See? So it has to be in the middle of the track and on grid. Otherwise it doesn't work. How's my compilation going? 78%. No, I can't move it. Seems to be stuck there somewhere. Oh, maybe it's stuck. Maybe it's actually stuck here in the corner. Yeah. Can we delete the marker? Delete marker? No? Delete? Yeah. Yeah. It got really messed up there in the corner. That's why it wasn't moving. So that's easier. Delete that one. Then I should be able to move these ones. Yeah, now it works better. Okay. And I have a connection here. This is the start of frame signal. This needs to go where? Over there. I'm going to move this wire a bit closer there so I can root out the connections. I also have this one. This one needs to go all the way there. This is the EtherCAT reset. Oh, right. It goes there. I thought for a moment I thought it was going there, but this one goes there. Okay. This would actually benefit from being remapped. But to what? Is there anything here? Maybe this one. What is this? This is the interrupt. Oh, that's cool. This is the interrupt. And this is connected there, which is bad for this one. So we can swap them around, this pin and this pin, and we can then connect this one here. Let's do that. So I have the SWRQ, and I'm going to move it on the processor side. So it's over there. It's right here. This one will go to where we have AP reset. Where is AP reset? Where is AP reset? There. And AP reset will go to there. So because these two are just GPIO pins, and all GPIO pins on the STM32 support pin change interrupts, I can just remap them together. I can just swap places of these pins, and I can remap them in software so that this one is then used as the RQ pin. Okay, cool. It seems correct to me. I don't think I missed anything here. I think this should work just fine. Okay. So no, wait. What happened here? This was not correct. So this one ended up on 140. Which one did I have there? Right, that was actually the EtherCAT reset. This was not AP reset, so let's go back here. Yeah, can redo that, and I'll take the EtherCAT reset. Where is EtherCAT reset? I'll just click on it. So EtherCAT reset. Wait a minute, that is AP reset as well. Wasn't this AP reset? This was right. Okay, so it's this one that's gonna swap places with this one. EtherCAT reset is there, right? So I'll move the EtherCAT reset. Let's see, I have to click here as well. Zoom it out a little bit, and let's see. So EtherCAT reset will move here, and then the RQ will move to the other pin there. So this should achieve the result that I want. it's not really a high-speed PCB. So doing like, I just try to make the layout the best way possible. But it's I wouldn't class this as a high-speed PCB because this is the only thing that's high-speed here would be the USB connection and the Ethernet connection. But the Ethernet connections are so short that they just go directly to the Ethernet transformer. There is very few high-speed signals, like really high-speed signals, and then we're talking about 100 megabit, for example. Anything that goes here to the motor drivers, it's 30 kilohertz, so that's not high speed. Possibly would be something that would be high speed would be the SPI connections, but I wouldn't class that as high speed either. I don't think I'll be running this SPI connections higher than 10 megahertz. So really, the only thing that could suffer from reflections would be the USB if it's too long. And I think this would be running. I would have to check exactly what frequency this would be running at to see what length would be half of a wavelength. But this is pretty much the only thing that I would worry about when doing differential, like really trying to calculate the differential pair impedance and stuff like that. Okay, so this should be remapped now, and I should have this section. This would be the KiCad reset, yeah, and then the Hall sensors. So the Hall sensor connections are a little bit impractical because this would need to connect this all the way there, when in fact I have another Hall connection that's placed here. So this one would be, select this resistor. So this one will be here. I have a Hall connection there, A1, B1, and the C1 is where? Right, it's on the other side. So this would be the C. And unfortunately, I can't remap this Hall connection anywhere else because all the other timers are taken. So this is the only way that makes sense to put it. Although possibly the encoder, I think that all the timers support both Hall and encoder. But I don't want to make too many changes to the board. So if there's anything I'm going to remap here, it's just be the going from the Hall 2 will go on these pins, and Hall 1 will go on the pins there. Let's see. So A2 goes there, A1 goes there, and B2 will go there, and B1 will go there. And then C was somewhere else. There it is. And the C2 will go there, C1 will go there. Okay. Get PCB from schematic. How's my compilation going? Okay, I'm just going to double check this. So we have B1, let's see, B1 to B2, A1 to A2, C1 to C2, and A2 to A1, C2, C1, B2, B1. That's good. So let's see. I always forget if I have to click the update PCB or not. KiCad is a bit inconsistent with that. Yeah, now I can close it. Now it's reconnected. And I mean inconsistent with other parts of the UI. So for example, in the footprint editor, if you press Ctrl S, it will actually open the save dialog again, even though the footprint is saved. Which is like little issues that creep up in KiCad, little bugs. Okay, the resistors then we'll need to connect. Right, I think this one will actually right, this one will need to be moved. So these ones will just swap places. Actually, I don't need to. Can I just move the part and have the tracks reconnect? I should be able to do that. If I just move this. Yeah, this is getting a bit messy. Okay, let's take them one by one. So this one, actually pair by pair. So this pair will have to go here and replace these resistors, which then go to B1. Oh. My escape key is right next to the mute key. Yeah, I'll just disconnect this. This needs to be disconnected because all the vias have the tracks. All the vias and the tracks have the different labels assigned to them. Take care of this one. Yeah, that's a long wrong track. I don't want to delete that track. If I just try to, let's see. So shouldn't this go like to number 1? And then it should go from here. Yeah, this should actually work fine if I only move the resistors where they should be. So these resistors need to go there. This would be the how to. Just place them there for now. C1 could go there, and then let's see, B, and this would be this pair. And then this one I shouldn't have actually routed this tracks. I should have reconnected the connections before that. Okay, so this goes. Let's see. I can move all of this stuff to the side, I think. Right. I'm going to hide the top layer. Yeah, now I could move it. It was stuck before. So kind of moving a few tracks one by one gets the other ones unstuck. I don't know why it gets stuck. It just does that sometimes. So this, maybe I can move this one also a little bit. This one is stuck. Yeah, this is KiCad's way of optimizing the tracks. It thinks that that's a good idea. I have to make sure that my cursor is precisely in the middle of the track when I let it go, otherwise it jumps back. Okay, so delete those tracks. I think I should have enough space now. Okay, and this will go there. Let's see, there. So presumably I could have a wire that goes through there and then up there, and then this one goes like that, and this one goes like that. So this can be a wire that goes there. Question is if I can. Let's see here. Yeah, it's quite possible I'll have to go on the back here, because there's not enough space here. Maybe move this along. I'll leave it like that for now. So this goes then to the hull connections that arrive from here, I think. Is this the, yeah, this is the hull connection. And that one and that one. And what is this? This is something that goes to this chip. This is actually one of the extra inputs, which could go to a GPIO pin. So if I could remap it, if I could connect it to some pin here, that would be optimal. But I don't know if there is anything else I could remap or swap places with. Okay. So this is essentially, yeah, A, B, and C. It would be nice if I could route it here. Just go on this side and then come out here and then go here. That would be optimal. So I think I'll delete the tracks. Did I just delete something wrong? Can I select the full track? Nothing else. And nothing else. Yeah. Right. So I think I can make them come out quite nicely here. I just move this a little bit. And that. And then I can go, I also need to move this capacitor though. I can place the capacitor here. And goes in the back. Could even move this a little bit more. Of course it's stuck now because the capacitor is there. Because if a pad of the capacitor is touching the track gets stuck. It's, yeah, now it's moving. Of course it has to be, the cursor has to be in the middle of the track for it not to jump back, which is a bug in KiCad. Maybe they fixed it, I don't know. Maybe latest version has fixed that bug. I'm gonna rebase to the latest Git version when I'm done with this board. And I think this should work pretty well. So I'll have first that one, which will go just side by side with this guard. It kind of has double functionality. It's both a guard, so that the router doesn't shove the trucks onto the area where I have the motor driver, and also it provides a bit of shielding for these signals from the motor driver. Okay, that one is perfect. That's precisely the way I want it. And this one goes there. Yeah, very nice. And I try to keep the tracks so that they are close together and don't take up too much PCB area, because that's nice when I need that PCB area for something else. If these tracks just go as quickly as possible to where they're supposed to go, and if they're close together, then subsequent routing becomes easier. KiCad apparently thinks I should go around this. I don't want to go around this. And it won't let me route. Come on. Click. No. Click. No, come on. To restart. Click. When I click, it creates this anchor point from where it then tries to route the track. So it kind of gets rid of that annoying functionality that makes the track go around. This is very nice. So I actually managed to route this track without any bias. Very nice. Okay, and about the, let's see, let's go like that. And this one got messed up as well. Is this SPI? What is this? Oh, that's the extra pins. The extra inputs. And this should actually be as close as possible there. So because I'm already using this area in the back of the PCB, moving things as close as possible is a good idea, so that if I need to route something on that layer, then I'll just have to jump using bias to the top layer and then go back to the bottom layer, instead of having to do this work afterwards when I need to free up the space. This is probably just better to do this way. What is this though? This is not even connected there. So this could actually go all the way. I don't like that way of going around. Maybe I can optimize this track. Yeah, let's do like this. So this is a filter capacitor for temperature sensing. I can move it out a little bit. Yeah, do like that. Yeah, this is perfectly fine. So this can go here, and then can follow this. There's nothing that needs to be routed across this area, so I can just go like this. Maybe even. No, it has to go, it has to actually go in there. Actually, maybe even it can go like this. So if it goes here, I can then switch the layers here instead, which would be better. I'll remove this first. No, come on. KiCad doesn't think that that's a good idea. And now it actually even stopped removing the redundant tracks. What if I do like this? Yeah, it worked fine there, but for some reason it doesn't always work. And then this one, well then, let's see. I kind of almost have an idea here. So if I go on the back here, and then even just getting here will allow me to go around this and around this, and I should be able to get to that pin. But I have to move this one first. Which it doesn't allow me to do. Maybe if I switch to a different grid, it'll work better. Yeah. And this one will go here. Very nice. I'm much happier with this one. And I could even continue with this track. That would be a good idea. Continue there. And then like that. What about moving this one as well? Maybe like this. Okay. Okay. Yeah. There has to be a better way. And I think I can see a better way here. Because this is definitely not the good way. If I can only lead it out here, and I can go around here, around this, it actually follow the same path here. I think that would be better. Yeah, so I'll delete that piece there, and then I can delete the rest of the track by selecting one and pressing the U key to select continuous copper, and then I can leave this one out here instead. Let's see. Actually, it's better to leave it out here, because if I still have a few connections to route there, and I have components on the back here, which means that I can use this area and reserve all of the free space for any future routing that I'll do. So I'll just go like this. Probably not. then I can just go here. And connect this through a wire to that track. So a lot of things are getting untangled here, which is good. Going back to this, to the hull sensors, I still have the hull connections for the second motor are still unconnected. I have to move these resistors in place. Maybe like this, because I have to have the other one there as well. So, yeah. So then this goes where? Right. This is the one that goes on the other side there. So I have to place these two here. And I could just go right here. And the other one goes there, and then there is another pair here. And then this connects to the tracks that come out there. There's two tracks. It would be nice to lead them out here somewhere, perhaps. Yeah, that won't work actually. So I have to. Is there any opening in the back layer where I can route them? Or maybe I could actually. Maybe I could, because, yeah, I think I could do that. Yeah, I can lead them out here, because these tracks, all of these tracks end before this space there. So let's see what I can do. First of all, I'll move these tracks. That would require me to move the canvas as well. Now I should be able to move it. So if I move these tracks there, and then I move this one No? Okay. Oh, right. This doesn't work because there are two tracks here that have just stubs. So I remove them for now. I'll move this for now. Okay. And then I should be able to come out here, so I have to remove these ones as well. I don't want KiCad to try to optimize this, because any attempt that KiCad makes at optimizing tracks usually fails. Why? Why? What sense does that make? There we go. And then this one can actually, right, I need to move those, or just delete them for now. So this one can move here, should be able to. Yeah. And now I should be able to leave the Hall sensor connections here. So I could do like this. Yeah, better to use a smaller grid for routing. Okay, come on. Let's see. Yeah, I have to switch layer here. So what I could do then is move this Y up a little bit. So this Y can go, let's see, this Y can go there. And without KiCad's stupid way of optimizing things, preferably. It can go there. And then this track will have a Y that goes here and comes out here. Okay. Actually, no. Actually, all I need is actually jumping this. And then I can just go like this. Okay. Now I don't have enough space here. So I have to move the tracks again. Moving things in KiCad is extremely annoying. Come on. No. Maybe I can move it like this now, without KiCad trying to, no, it's still trying to optimize. There we go. That's a bit better. And then I need to move this one as well, just a little bit. Problem with this optimization is that I can't easily revert it later. So it's fine that there is a little bit of space there. I could easily just push the tracks back. But if it tries to optimize it by doing that, then I can't easily revert that later. Now, so this will go here. Just connect to the other hot connection. No. Start again. No. Restart. Click. And click. Come on. A little bit more space here. Let's see, do we need to, yeah, we need to connect here. So, yes. That's better. And then this will go around here. So I move this Y here. And this Y can go here. Come on. That's the way I want it. Thank you. Finally. This one is actually unconnected. And the ground connection. And wait a minute. Right, so I need to... this will have to be on the back, of course. So like that. I need to actually move them a little bit. Let's see, I'm going to move this one here. maybe actually, in order to wire this ASD protection, I think it would be, let's see. It would kind of be better if that was the C, and then this, let's see, so this can be removed. So, and then the track comes in on the back here, connects here, and then goes there. So this would be, so C2 has to be connected to B. I'll just do a simple rewiring of this. We have pin number 1 would be the B. Let's see. So pin number 1 will connect to B. Right. This would actually require me to move the resistors as well. But that's easier than trying to wire them with the same resistors, the same resistor wiring. So 1 goes there, 2 goes here, so 2 goes to A. And then this last one goes to C. Okay, and the resistors need to be moved as well. So this one goes to this. Yeah, let's update the PCB. It's going to be easier. So then this one goes here. And this, let's see, this is C, this is B. And this goes here. And then the C goes here. Alright, and routing this is easy now. Just do like this, and ground, and this one goes through the opening there. And then this one goes through here. one connects there. And this one then goes to the remaining wire. So the remaining wire needs to come out as well. And actually, this will have to go between here. Yeah, nice. No, come on. Right, so this can come out. This needs to go there. Yeah, maybe if I, let's see, maybe if I route this one around, then I could make that wire come in here. Okay, can I lock this track or something? Lock? No? Locking? What is going on now? All of a sudden it stopped caring about any DRC rules. I think that even though this is not a high-speed PCB, it's still a good idea to pay attention to the routing and sort of do it the best, like do it as well as possible for this PCB, because it's better to spend a bit more time on routing than to have to debug problems later. So this can go then here. Alright, so just bring it out there, and then it can go straight. Let's see. Yes. Actually, what about doing it like this? I can save one connection there and make the layout a bit better. Just by moving these resistors closer to the SD protection die. Just move them like this. Yeah, this should work fine. And this goes here, this goes here, and then this goes finally to the input pin. Okay, I'm a bit more happy with this board now. So, anything else here that needs to be connected? So this goes here, this goes to ground. That's KiCad's way of optimizing the connections. Yeah. I wonder how well that will work. Okay, this needs to be moved a little bit here. And then we have the ground here. Which is actually, this would be better to, can I modify this easily? Yeah, this is custom KeoFan, so I can just open it and put the filter. And I'm gonna add pads here. 0.2, 0.3, and 33. Is it possible to hide the shape? I want to see underneath it. Okay, so I'm gonna place these pads around the ground here, so we can have, let's see. I'm going to duplicate this pad first of all, and I'll disable the mask on the larger pad. I'll make it a bit larger, so I can make it like 2.5 maybe. Let's see if this is enough. Actually 2.6 would be better. So I don't want to place vias straight through the pad. I want to place them on the side. What is this? Okay. What if I hide this? So this one is not even supposed to be there. This will have to do. Okay, so this connects to ground now, and the ground pins can have their own bias. And then this one needs to go all the way there. So wait a minute here. So I had another PWM. Where did I connect that one? Let's have a look. Pin 12 there. So no optimization there. I'll just have to fix the tracks here. This one, call like that. All the weird stuff that KiCad makes with the tracks. Although the push and shove router is very nice. It kind of brings KiCad to much higher level, much closer to the level of professional packages. The non-free packages. There we go. That's good. Yeah, I know I can place the via there, but if I edit the footprint, then my vias get automatically updated on all of the instances of this chip. So I had the GND vias placed manually using the place via tool, but doing it through the footprint, I find it much better, because then I just update the footprint and all of the instances get updated automatically, and I don't need to duplicate the work of placing the vias. So much better, I think, to update the footprint. Especially when you have footprints that look like this, where you have lots of vias, and where you have bottom copper plate and the top copper plate that needs to be connected. Then it's much better to update the footprint with the pads than to place the vias manually. What kind of project with GSM GPS? Do you mean like a GPS, like something that is a motor controller with GSM or GPS, or do you mean something else? Okay, so this one, there are a few things left here. I have the 5 volts connection that needs to go. Let's see. I don't really want to place it underneath the chip. I can place it here. Okay, no, I'll have to do that, but I'll have to move this one first. Do it like this. And this is, right, this is the pin 23, so this is actually, I think this is not actually a power pin. Or is it? I have to check. Pin 23 is just connected to 5 volts, but it's not actually, it's just a signal pin, so it doesn't need to have any special considerations. I can just wire it like this, or like this. This is better. And just lead it here and then through a wire to 5 volts. So I'll have a copper area that will cover the power layer, where I'll have 5 volts. And I'll have to have 5 volts and 3.3 volts. So I just have to make sure that it doesn't mess up that last track there. Yes. Do I have enough space for a wire here? Maybe not. I can do it like this. Nope. Not enough space. So like this. That's better. Yeah, you want a power converter, but maybe I don't feel like designing one. Regarding the GPS and GSM primarily, I think it's much better to use modules that already come, like which you just control over a serial port, which is just very easy to use, and there's no need to design the actual GSM modem. And I think that if you just get a GSM module, you can easily communicate with it using an Arduino or something else. So in that case, it would be a pretty boring project to do, unless it has some other functionality, of course, which would be such as, for example, a motor controller maybe that has this GSM modem built in order to. I don't know why you would want to have a GSM modem on a motor controller. But yeah, it would have to be some fun project that has some other functionality besides just being a GSM modem with which you communicate from a microcontroller. So this one, PWM, this needs to go here. I'll move these tracks a little bit. Now I can't move this track because this track is stuck because of the wire there. Maybe I can move it now. No, can't move it. It's very prone to messing up my other tracks. So I'm just gonna abort it. I'll just do like this. You have to be very careful and let it go just at the threshold. Can I move this one? Yeah. There we go. Yeah. Maybe KiCad has fixed this in later versions. This is KiCad 5.01, I think. I'll have to rebase to the latest release. Why is this not moving? There's a little piece of track there that I think messes everything up. So if I remove that track, then I can move it. But maybe not too much, maybe just like that. That's good. How's my compilation going? It's done. So what do we think? Is it time to test if I have the ability to assign a shortcut for corner creation? Let's see. I'm just firing this up. Let's see. So I just opened the PCB in my newly compiled version, but I'm not going to do any changes. I'll just check if let's see, if I can make corners easily. So preferences, I think it was hotkey, edit hotkeys. We should have an option now for creating corners, if my little edit worked. No? Really? Did I miss anything? It doesn't appear there. So maybe it was not enough to just let's see. Maybe it was not enough to just edit the code and add this. Let's see, where was it? Where was I? Hotkeys. Where was the code that I added for the creation of the menu item? Let's see. On Rightclick. Okay. So maybe this was not enough, or maybe what is this message that it returns? Menu item. Right. So there is. Okay. This should be a message. Although I don't think that would affect anything regarding the hotkey itself. But apparently it's not enough to just add, to just call add hotkey by name. There's probably something else I need to do. Or maybe, maybe this is, let's see, this is actually called when I pop up the menu. So let's check this out. Create corner. Yeah. And what about keys? Create corner. Probably need to do something else because this is clearly not the place where it actually initializes all of the hotkeys. Add hotkey name. What does it do? Add the key name from the command ID value. Is hotkey. Okay, this is just for creating the string. I'll have to look into this a bit deeper and determine exactly how KiCad is creating the hotkeys and why the hotkey for the create corner doesn't appear in the list of hotkeys. So I'm gonna just open my previous version of PCB new, not the latest one which I compiled, and I can just continue with the layout for now. Maybe I'll make a video about adding hotkeys for creating corners once I figure out how to do that. Okay, so this needs to go there. This can actually just start from the back. Now I can remove the tracks that I've had there before. This one. Let's make this better first. Like that. I wish I could like click on the track and just drag it. Can you do that? Yeah, I can do that. Awesome. Doesn't always work. And doesn't behave the same way according to the settings that I have for creating a track. So I've purposefully disabled the functionality of shoving the components while I'm creating the track, because I don't want KiCad to try to optimize my routing. But if I drag the track, then that functionality is enabled, which kind of makes sense, because it considers even dragging the edge of the track or the end of the track as a drag operation, and it should do the pushing and shoving when I'm dragging the segments. Let's see, so this goes then there. Okay. I'll leave that for now, like that. Maybe optimize the placement of these tracks later. I need to untangle this mess. There's still a few things that need to be routed here, which are important. So this goes up there. And this, yeah, this input is impossible to remap anywhere. This has to go there. So it kind of needs to, let's see. It needs to go around, but I need to make sure that I don't have anything here. What if I route this track on the top layer until somewhere around here, and then go to the bottom layer, and then I should be able to and then I should be able to drag this break input. So the break input is going to be, it's connected to one of the 40-volt inputs on the encoder interface, and it can be either used as a way to have an emergency brake, where if you supply a signal on this input, then the hardware automatically stops sending any PWM to the motors. So it's not break as in stop, it's more like break the circuit. That's what it does. I need to route this somewhere here. Where can I make this pin come out? Where is this signal gonna go? I'll have to probably go around here somehow. So I'll have to move this wire here. Since I'm not really sure where I'm going to route it, I'll start by simply trying to bring the ends of it close. So I'll bring them a bit closer together. I'll route it here to begin with. And once wait a minute, this is the wrong pin. This is possibly for the, this is PWM. We have actually two break inputs. So we have one here. Let's just control click on it and see where it has to go. It has to go there. You can move this via a little bit. Maybe it's better to just move it. I have actually two options here, so I can either route it in between there, which will make it come out somewhere here, which is suboptimal. I should actually route it here and then jump underneath these ones and then come out somewhere here. I think that would be the quickest path. But I also have these wires that need to be connected. This is I to C. I have a little bit bad layout for the I to C because it has to go there and then there, so it has to cross a lot of tracks. And I can't move this chip anywhere else because this chip has to be here. It has analog signals going to both motor controllers. So either I would have to replace this chip with something, with two chips, where I place each one of them on the area of the motor controller, and have I2C go like that, or I have to have this chip as close as possible to both of them, and just have one I2C connection, which is better. I mean, it's better to have just one I2C connection to this chip here than to have I2C that goes all the way across there. I can show you how to create BOM list in KiCad. So the way that I work in KiCad is a bit different from how KiCad usually it's a bit different from the standard way that people work with KiCad. And I think that KiCad is moving in the wrong direction when they add things like this. So they have added this little utility here where you can open it up, and you have your list of all components where you can sort of assign fields in bulk. I think this is a step definitely in the wrong direction, because all of the fields should be modified in your component library. Doing it that way makes things a lot easier when you have to duplicate components and instantiate components. So if you have like different instances of a component, you want to naturally have the same values for all the fields in that component, including the manufacturer number, which is the primary reason that I use a completely different workflow in KiCad, because I want to have the manufacturer numbers saved in each component on the schematic, but not actually on the component on the schematic, but rather in the library. And then I just do update fields. There is a function here, update field values, and I modified this a little bit to properly modify all fields. I can show exactly which changes I've made, and I think I have it in my GitHub where I keep the copy of the KiCad code. So I just do the update of all the fields, and all of the instances get automatically updated to field values from the library, so that when I need to generate the BOM, it's very easy for me to do. Let's see here. I think it's hiding here somewhere. Here's the BOM. So then I just use the built-in plugin for the BOM. I generate this BOM, and it's going to write the CSV file. It takes a while because it's a large schematic. And now I'm just going to open this BOM and then bring up the window so you can see what it looks like. So when I then generate the BOM, I completely eliminate basically the step of assigning footprints after you're done with the schematic, because that's how KiCad seems to force you to work, and I don't have that step at all in my workflow. I assign the footprints when I'm adding the components to my own library. Like when I go to a supplier, I look at the component, I look at the data sheet, and I add all the values that relate to that component into my library. And then from my library, I add the component to the schematic. So when it's placed on the schematic, it already has all of the manufacturer codes and any other fields already assigned. And the BOM then looks like this. So I have all of my references, and I actually also have then the manufacturer code here. Let's see, where's the manufacturer code? Here. So it's already assigned. Some of the codes just have numbers, so they appear like justified to the right. But this is basically what I then copy, and I create a BOM list that is specific for for a specific manufacturer of the PCB. So it's really easy. And if I need to replace a component, so basically every component in my schematic, as you can see with the resistors here, for example, every component that has a specific value is a separate component in the library. So I don't use, like the way KiCad would, you have kind of your templates in KiCad, like normally you would just click like this, you'd pick a resistor, and then you just assign the value of the resistor here. That's bad workflow, I think. That doesn't simplify things at all. Instead, what I do is I have my own library where I then have all of these components. Let's see. Can I go to properties? Yeah. And in my own library, I have components named after like prefixes. So resistors always start with res, and I actually add the resistance as text on the resistor component. And then I can easily, so I assign the manufacturer number, and then I have a script that pulls in all of the other fields through an API. So you could use an API, like for example, Octopart has an API, Mouser has an API, and you can easily call Mouser API from Python, and then import all of these fields directly into the library. So I use the KiCad library utils, which is an open project. I modified that as well, and I have that should be in my Git as well. And then I have scripts that directly modify the library. And if I need to add another resistor, I just copy this. I create a duplicate symbol, and then I assign a separate manufacturer code to that particular resistor. And I think this makes things so much easier. And it's also less error-prone when you have multiple instances of components. I think this is the proper way of working with KiCad. So you should basically see all of the symbols that are in default KiCad library as templates. They're not supposed to be used directly on the schematic. They should just be used as templates. So you can use their symbols as templates. Then you create your own library with your own components where you assign your manufacturer codes. So that's that. I'm just going to go through the chat and see what other messages you guys have written. Can make BOM, right? How does you don't need to find a plugin for the BOM list. KiCad already has those plugins. And Damien posted a link which got blocked, so I showed that link. All right. Yep. Okay. And also, I'm gonna add separate reference supply here. I think vref could be connected could actually be connected to 3.3 volts. But what I'm definitely not gonna do is have it connected to the same reference supply as the ADC, because this requires a very long connection going all the way there. I'll have a think about that. Maybe I'll either connect this to 3.3 volts, or I'll add a reference regulator just like I did here. For the STM32, for the ADC supply, I have a separate reference LDO, which is a high precision LDO that provides precise reference. So I wonder what else I could do here right away before I stop this video. I have 3.3 volts there. This one is 5 volts. This one is 5 volts. So 3.3 volts needs to be connected. 5 volts needs to go there as well. I'll solve all of these things when I go over the power layer. So I'm just trying to find some connections that I can route right now. The gain selection. Let's see, gain selection for that one goes there, and gain selection for this one. Let's see. This goes there, so they pretty much connect to almost the same place. So I don't think I can optimize anything there. This one. I'll use a thinner track. This is the DC cal. DC cal should be. I really don't want to route it there. I'm gonna see where I have DC cal connected here. So this DC cal goes. Yeah, unfortunately, it has to go there. I think that most of the pins here are basically impossible to remap to anything else. Besides this one. This one, definitely. This one will be definitely swapped. So this goes, so my DC cal, is it DC cal? DC cal 1 and GPIO reset. Let's see. Which are both GPIO pins. It doesn't really matter where they connect, but doing this swap simplifies the connections. Damien, what do you mean they are there? What do you refer to? Okay. Maybe I should remap them as well. So I have gain and I have that. And all of them are GPIO pins. The question is, what would be the best way to connect them? Let's see. Right, I forgot this one. This one is definitely going somewhere here. What is this? Okay, that's impossible to remap. Do I have anything here I could use? Can't use HAL. I probably cannot use this one now. This is boot pin. Did I? Right, the GPX reset, definitely. So that's the second GPIO. Let's see. So N-gate 1. N-gate 1 can go to where I have GPX reset. That's the second SPI GPIO chip. GPX reset there. Oh, I see. Maybe I had to add them manually. I don't really remember. So maybe they're not shown automatically. Alright, so this is better. Much better. This can go here. And if I only have enough space, which I don't. Perfect. I would appreciate if KiCad would move the tracks back when I move away. Okay, I'll leave that for now because I may actually need to move them depending on where I route this one and this one. Yeah. This would be the gain. Can route this one. Okay. Cleanest solution here would be to actually swap places of gain 1 and DC cal 1. So I don't have to have like a track that goes around here and have a via there somewhere, and then route like that. Yeah, which I can do. This is no big deal. So this goes then. Let's see. I just want to see what I have the last one. So the last one is I'm going to route all of them and just make sure that they all can be easily routed. Okay. So is there anything else here besides the vref? Fault and overcurrent warning. So fault goes, fault would probably need to be reassigned to something else. Sometimes the initial connections are not optimal. It's really hard to tell from the beginning how things will be placed on the PCB. I'm just waiting for the dialog to pop up. There we go. And then I can just move. Let's see. I'll move this one a little bit to the side here. To save as much space as possible. I should probably disable the push and shove completely. Okay. 1 and DC cal 1. Okay, that's a bit easier. And on this one we'll go right. And then actually this one can swap places with the gain. Gain 1. And I'll also then swap our current 2 with our current 1. Which will make this connection a lot easier. So they don't have to cross like that. And this goes there. Just need a little bit more space there. No. KiCad doesn't want to let me place it there. I have to make sure that the cursor is at the center when I let the mouse go. Otherwise it goes back. This one is not going to be moved. Like this. Alright. Very nice. is this? This is some track. Huh. No way. What did KiCad do? Okay. So this can be deleted. Okay. So I can also connect the Hall sensors here, which is going to be just very short connections. Perfect. And then this ground needs to go somewhere. And the vref. Could this be coupling to the vref? So close. Vref comes in here from a regulator. This is a precision LDO, and it comes through the ferrite bead, and then goes to the pads and the capacitors here. And this is, I think this is, one of them is vref, and then one is VDDA. Yeah. So just the grounds left here. What is it complaining about? Is it... Is there a piece of track somewhere? Why is there no connect there? That's very weird. This goes to 3 to 3, and this is supposed to just go there. Oh, right. So this track was not connected. It wasn't actually going all the way. That's why. I'm going to delete that and just redo this track. And that didn't solve the issue, of course, because it's something else. Right. Could it be actually pointing to this one? I think it's pointing to the power plane, which is here. I think it's pointing to this one. If I refill the planes, maybe it works then. Yeah, that seems to have solved the issue. So I was just going to the power plane. Okay, still a few connections left. And it's like the hardest ones left now. Just trying to figure out how to get the last ones to connect properly. Let me try that. Control W. Yeah. Good. Thanks for that one. Is there a shortcut for placing a wire? Like, I would like to have it assigned to W instead of the track width, just like in E schema. I'm gonna look at that, at all the shortcuts when I have time. But if you know, Damien, just tell me if there is a shortcut that can be assigned to placing a track. So EtherCAT reset, that goes to the EtherCAT connection there. And probably I can just also switch these two. So EtherCAT reset and GPX CS. These two can definitely be swapped. Rotate. This is a bit ugly. Can I drag that one? No. Okay. Yeah, I don't want to mess anything up right now. Just having to move all of this around. I'll just leave it the way it is. Just continue with the layout. Alright. And maybe this can swap places with this one. No? Yeah, this one's can definitely swap places. Or no, actually no. Let's see, kind of didn't. Yeah. What about this one? Yeah, this one. This one's a perfect candidate, I think. If and there's this one. Right, so vmod sense, I can't reassign that unless I assign it to some other channel. These two interrupts. Yeah, I'm gonna take a break now. I need to eat some lunch, so I'll be back in an hour or two, depending on. I'm probably gonna take my dog out as well. It's been amazing that she's been sleeping for so long. Like, she usually wakes up much quicker and starts to get annoyed by me not going out when she wants me to go out. So we'll see if I'm back in 2 hours. Otherwise, I'll continue later. Thanks for watching. Bye.